Hello, and thank you for joining in this introductory webinar on health and safety. My name is Eric Bensala. I am an energy advisor at OPPD. If you have any questions or comments at the end of this webinar, please send me an email or leave me a voicemail. In today's webinar, we won't be looking at general electric safety, but rather health and safety in our homes through a look at indoor air quality and combustion safety, as well as looking at moisture management and the technology available to monitor and test your home. Please note that we will not get too far into the weeds in each of these categories. This introductory webinar's design is to give you an idea of the things to keep in mind in your home when it comes to health and safety, as well as what you can do to monitor the situation and even resolve it. For information around general electric safety, visit our website at OPPD.com, and under the Community drop-down menu, you'll see Electric Safety. Indoor air quality is often overlooked, but there are a number of things that can contribute to reduced indoor air quality. The three main areas we're going to look at in this section are carbon monoxide, radon gas, and VOCs, or volatile organic compounds. Carbon monoxide is the most well-known of the indoor pollutants. It is a byproduct of incomplete combustion from things like gas furnaces and water heaters to cars and cigarettes. Carbon monoxide levels are measured in parts per million, or ppm. At lower concentrations, as little as 5 to as much as 50 parts per million, flu-like symptoms can occur and will often go unnoticed, especially during flu season. Higher concentrations, however, those over 50 ppm to as much as 3,000 ppm, can lead to severe headaches, vomiting, and be potentially fatal. The EPA's, that's the Environmental Protection Agency's, suggested max exposure for 8 hours is 9 parts per million in room air. Higher concentrations of carbon monoxide, as previously mentioned, are a byproduct of incomplete combustion, which can find its way into the home. For example, gas furnaces and water heaters vent their gases through a flue pipe using the stack effect. But if there are pressure issues in the home, carbon monoxide could vent back into the home. We call this backdrafting. Some other causes of carbon monoxide are an inadequate amount of combustion air, burner misalignment on a gas stove or other appliances, and flame interference. Testing for carbon monoxide is fairly straightforward and varies in cost. There are sensors you can buy that show the parts per million of carbon monoxide in the area. This is a more passive but very informative way of testing the levels in your home. A carbon monoxide tester is used at the source of carbon monoxide, in other words, where the combustion gases leave the heat exchanger before they're diluted and sent up through the flue pipe. It is always recommended to have a carbon monoxide detector or a few of them in your home, especially in living and sleeping areas. These plug into a regular outlet and many come with a battery backup. The primary function of a carbon monoxide detector is to alert you when the concentration of carbon monoxide becomes too great, meaning you need to evacuate the home and call 911. Unvented combustion appliances should operate with next to zero carbon monoxide production, whereas vented combustion appliances should produce only 100 parts per million or less. Radon gas is another indoor air pollutant. However, this one comes from the ground through the rocky soil we have here in the Midwest. The concentration of radon varies widely, not only here in the Midwest, but in other regions where radon gas has been detected. Health departments and private contractors who specialize in radon mitigation can perform reliable tests on your home for radon. Some tests can be as short as a few days to some that may require months to gather radon levels. The EPA states that a home with radon concentration higher than 4 picocuries per liter of air should be mitigated for radon to reduce the concentration. If it is determined a home will need mitigation, there are a variety of ways this can be done by the contractor you hire. Installing plastic ground barriers and carefully sealing the seams, sealing walls and the floor of the basements or crawl space. In almost all cases, though, a fan system is connected to these strategies to help depressurize the soil, moving the radon gas out of the home. VOCs, or volatile organic compounds, are incredibly common in the home due to where they come from. Aerosol sprays, the burning of wood that has preservatives in it, air fresheners, paints, and other solvents too. Outside of those chemicals, VOCs are also a byproduct of building materials, especially in new construction. Varnishes, office equipment like copiers and printers, adhesives, and even permanent markers. The health effects of VOCs vary widely, but some of the common symptoms of overexposure are dizziness and fatigue, nausea, headache, nosebleeds, shortness of breath, and more. These symptoms can lead to an irritation of the eyes, nose, and/or throat, headache, coordination issues, nausea, and even liver, kidney, or central nervous system damage. There are a variety of ways to mitigate the effects of VOCs, if not completely avoid them altogether. Ventilation is one of the main strategies. Always be sure when you're using any VOC product that you have adequate fresh air flow. Another strategy, which might seem obvious but is often overlooked, is the precautions on the label of the product. Those precautions should be followed exactly as written, if not even in excess of what is recommended. Additionally, with VOCs, only buy what you need and be sure to dispose of any unused containers and ones that were hardly used in a safe manner. Never, ever mix any VOC products unless directed by the label to do so. And, as always, keep VOC products out of the reach of children and pets. Let's jump on over to combustion safety. We referenced some parts of this in the carbon monoxide portion, but let's unpack this a bit more. In our combustion safety segment, we're going to look at flame safeguarding, heat exchangers and the role they play in combustion safety, backdrafting, and of course, mitigation. All HVAC systems should be inspected on a biannual basis. This is particularly key before the winter months with gas furnaces. These inspections make sure the components of your furnace's heating elements are working properly and safely, which includes flame safeguard controls like a high limit control switch extinguishing the burner in the event of overheating. Flame safety controls help protect against fuel delivery into the combustion chamber without ignition. A lack of this can lead to a fire or even explosion. The three most common flame safeguards are the thermocouple, flame rectifier, and photocell. All three essentially act as a safeguard against fuel being used without an ignition source. Cracked heat exchangers are a significant safety problem but are specific to combustion furnaces and room heaters. A cracked heat exchanger can allow combustion gases to mix with the air in the home, posing a serious health risk. Heat exchangers can crack from rust, excessive heat, and even weld failure, to name a few. One of the most important parts of a furnace inspection is the verification of the condition of the heat exchanger. HVAC technicians can do this test in a variety of ways, such as a remote camera, shining a light into combustion chamber to see if the light leaks out anywhere, chemicals or smoke injection, or even by observing how the flames behave when the blower is running. Some of the causes of backdrafting can be narrowed down to these 4 points. Suction near the furnace or blower, which can be caused by leaky ductwork, powerful exhaust fans, clothes dryers, and even fireplaces. A blocked chimney, a chimney that is too large or too small, and even high winds. All of these cause pressure differences in the home, which can lead to backdrafting of the flue gases. The mitigation of these issues comes down to sealing any leaky ductwork. For more information on how to do that, see our airflow webinar. Also, repairing your chimney if there is any damage to it or any known issues you're having. A more active step would be to provide outdoor combustion air. And with that being said, many modern furnaces have an inducer motor to help the venting of the flue gases. All right, let's move on into our moisture segment. Moisture management is an incredibly complex and nuanced area of health and safety. For the sake of time in this introductory webinar, we are just going to look at some of the cautions of moisture management as a whole and then get into water leakage and water vapor, which includes humidity. Moisture condensation and its mitigation is important when it comes to our homes because water can lead to a building deteriorating over time, not to mention also by biological pests being drawn to the moisture. These pests also have a dual threat of posing serious risk to respiratory health. Water, as we know, will eventually corrode metal. It can also dissolve any glue that is used in construction materials. Water and moisture can slowly but surely warp wood and even weaken mortar. Insulation ends up in places in our homes that are prone to moisture if proper air sealing isn't present. Moisture can ultimately reduce the thermal resistance of insulation and potentially damage the insulation. When it comes to water leakage, there are some fairly simple measures to help keep excess water from penetrating your foundation. This includes, but is not limited to, keeping your gutters and your downspouts clear of leaves and any other debris that accumulates in them. If you have trees around your home, especially silver maples, you may want to clean out your gutters 2 to 3 times a year or more. Also, make sure the water empties at least 3 feet away from your home's foundation. Downspout extensions are great for this measure. As far as your roof and walls are concerned, be sure to repair any roof leak you find immediately. Failure to do so can result in having to replace your roof depending on the severity of the leak. Also, try to have any air leaks sealed that exist between the indoors and the attic. This will also help prevent ice dams. Switching gears in our water category, let's look at some of the common sources of water vapor or humidity. Obviously, a humidifier, but also doing your laundry. Plants, the shower and or bathroom, and even crawl spaces all contribute some amount of humidity or water vapor in your home. Of course, some a little more than others, but every little bit adds up. So how do we mitigate this? A dehumidifier works well if a particular room has humidity issues, but they are not meant to solve the issue for the entire home. Additionally, dehumidifiers can get expensive if they are running 24 hours a day. Other measures include installing outlet gaskets on any exterior wall outlets or switches, sealing any holes or cracks in your walls, especially exterior walls, sealing the floor wall junction, and sealing or adding weather stripping to your windows and door frames. A more difficult but effective measure is to air seal around air conduits like plumbing chases, wire holes, and the likes. Now that we have some idea on what we're looking for when it comes to the health and safety of our homes, let's look at how we can test our homes and keep us and our loved ones safe. The technology available to use in the home for health and safety really serve the purpose of measuring your current situation, which allows you to mitigate based on those measurements, and finally, maintain a healthy and safe home through frequent measurements. Let's look at what we can use for this process. The 3 main devices used for the home are carbon monoxide meters, an air quality monitor, and the tried and true carbon monoxide detectors. Carbon monoxide meters are battery-powered devices with a variety of features, but are used to test at the source of where carbon monoxide is generated. Carbon monoxide detectors do just that. You plug them into the wall of your living and or sleeping space to alert you if levels have gotten to unsafe levels. Be sure you purchase one with a battery backup. Lastly, the air quality monitors are one of the more technologically advanced devices. Some of them can even connect to an Alexa to give alerts if certain levels exceed safe thresholds. These monitors do just that. They provide digital readouts of the levels of various compounds in the air like carbon monoxide, formaldehyde, VOCs, and more. We do have some additional resources around health and safety at our website at oppd.com/EE, which stands for energy efficiency. Some of the topics discussed today are broken down a bit more, but you can also find information about energy efficiency measures for your home and other things like do-it-yourself videos throughout those web pages. This concludes our introductory webinar on health and safety in your home. Thank you for watching and have a wonderful day.